Hello everyone. This is one of the problems I found on the ESAT uh, problem archives. This is not a US based system, rather a UK based entrance test commonly used in Cambridge, UCL, and Imperial. And yeah, that's it. Started. We got a circle equation. So because I saw this as a circle, I'm going to use a geometrical approach with some algebra, and we have to find the greatest possible value of 2x plus 3y. So x square plus y square equal 1 is just a circle with a radius of 1, and I'm going to do this in a coordinate form. So this is going to be x axis and this will be y axis, and to find the greatest possible value of 2x plus 3y, we have to let the greatest value as k, I guess. So 2x plus 3y be equals k. And to get this in a simple y equal mx plus c form, it will be y equals minus 2 by 3x plus k by 3. And we'll start with y equal minus 2 by 3x. And it will be something like this. It will be a negative slope. And let's just say this is L1, which is minus 2 by 3x. And to get to the greatest point on the circle, that would be probably somewhere here or here. Most likely here because this is positive and this is negative. And since L1 can take the value of any k, we have to find the value of k such that the intersection of L1 and the equation x squared plus y squared equal 1 only touches once. So we have to use the discriminant form to find the value of k such that it touches only once. So yeah, y equals minus 2 by 3x plus k. Let us say k is a constant y-intercept, and in equation x squared plus y squared equals 1, so we can substitute the value of y in terms of x. It would be x squared plus minus 2 by 3x plus k whole square equals 1, and we get x squared plus 4 by 9x squared minus 4 by 3x k plus k squared minus 1 equals 0. And we have to figure out b squared minus 4ac equals 0 and find the value of k. Here I think it would be 13 by 9x squared minus 4 by 3 kx plus k squared minus 1 equals 0. And b would be minus 4 by 3k, so b squared would be 16 by 9 k squared minus 4. A would be 13 by 9 and c would be k squared minus 1 equals 0. And we multiply both sides by 9, so we get 16k squared minus 52k squared plus 52 equals 0. And for k squared we get 52 divided by 52 minus 16, which is just 13 by 9, and k would be plus or minus 13 by 9, but to find the greatest value we just have to take the plus, so we'll neglect the negative one. So we know the line 1 with complete information, which is y equal to minus 2 by 3 x plus root 13 by 9. But to get this point, which is highest value, we need the x and y's value. So to get the x and y value, we know that line L has shifted here, and I'll just draw it out. Since line L has shifted here, we can find the value of x and y by drawing a perpendicular line to L1. So it will be like this. Since it is perpendicular, we know that if a line is perpendicular to another line, the gradient is minus 1 by m. So for, let's just say this is L2, L2 gradient would be 3 by 2, since L1 is minus 2 by 3. And L2's equation would be y equals 3 by 2x. And to get the x and y value, we'll just have to find the intersection point. So 3 by 2x equals minus 2 by 3x plus root 13 by 9. And we multiply both sides by 6. Okay, wait a minute. I think I got something wrong here. It should be 3, not 9, since we took the square root of 9. And here too, it should be 3 and 3. So we multiply by 6. We get 9x equals 4x plus 2 root 3, which would be x equals 2 root 3 by 13. This is the x value, and we can find the y value in 3 by 2x, which is 13 by 13. Cancels out 3 root 13 by 13. And since we have to find the greatest value of 2x plus y, we get 2x plus 3y. 2x would be, what do we get for x? X is 2 root 13 by 13. 2 root 13 by 13 plus 3. Y's value was 3 root 13 by 13. 3 root 13 by 13, which comes out to 9 plus our 4 plus 9 is 13. So 13 by 13 equals 13. So in our option, the correct answer is G. It's supposed to be a multiple choice question, but it's rather taking quite long. So if you have any other suggestion, let me know if this can be solved in a more easier way. Remember that we can only use a digital calculator, and not, since this is not a SAT version, US SAT version, we cannot use Desmos. Thank you, everyone.